Control valves are valves used to control conditions such as flow, pressure, temperature, and liquid level by fully or partially opening or closing. Traditional control valves are the most basic type. The flow control of a traditional control valve is typically limited to fully open, fully closed, or fully switched to a new flow path. Traditional control valves are of simple design and capability. Changing direction, flow, or pressure during machine operation would require a complex hydraulic circuit. Each desired direction, flow, or pressure would require an individual traditional valve to control it. Proportional control valves offer a solution to the complexity dilemma without introducing dozens of valves and hydraulic loops to the system. Physically, proportional valves appear similar to their on-off solenoid counterparts. The big difference is in the way their solenoid coils perform. Proportional coils operate on DC current and produce varying voltages that in turn produces a variable force to shift the spool. The graphic symbol for this type of solenoid shows the solenoid slash in the operator box with a sloping arrow through the slash. With proportional valves, the spool can be shifted against the centering spring force to any distance up to full shift by varying voltage and current. As the internal valve spool changes position, new flow areas open up gradually and continue to open wider during full spool travel. To eliminate flow lag from spool overlap, most manufacturers cut V-notches that allow some flow to pass as soon as the spool moves. Proportional control valves allow for variable control of spool movement, which allows more step control and metering of flow, speed, and direction. Most valves of this design are used in open-loop systems to smoothly accelerate and/or decelerate an actuator or cylinder. The proportional control valve allows for a simpler hydraulic circuit, but it is not accurate over a broad range of pressures, flows, and temperatures. Neither are they highly responsive. Proportional valves offer a variety of machine cycles which can safely be operated at greater speeds and result in improved machine cycle times and production rates. The third type of hydraulic directional control technology is called the servo valve. First developed in the 1940s, the servo valves operate with very high accuracy, repeatability, and high-frequency response. Servo valves are highly responsive and capable of handling minuscule flow changes both rapidly and accurately over a broad range of flow rates, but at an extra cost. The main difference between proportional and servo valve circuit design is that servo systems have a method of feedback that assures that the actuator is doing what the controller tells it to do. Most industrial applications use feedback from electronic linear, rotary, or force transducers. A transducer is a device that produces an electrical signal in direct relation to a position, force, or speed. These devices feed a precise position or speed indication back to an electronic controller via a feedback wire, which in turn adjusts the valve. Fluid from the pump inlet is tapped off through filter elements, passes through orifices past both ends of the spool, goes on to nozzles, and out to the return line. A feedback wire attached to the flapper terminates in a ball end that sits in a very close-fit slot in the spool. When the torque motor coils receive a current signal, the armature rotates clockwise or counterclockwise and pushes the flapper closer to one nozzle and farther away from the opposite one. This allows pressure to increase at one end of the spool and decrease at the other. The spool then starts to move away from the higher pressure. If the armature turns clockwise, pressure builds on the left end of the spool and it moves to the right. With these very accurate feedback devices and a fast response servo valve, an actuator's position, speed, and/or force can be repeatedly established within an extremely close range. Electronics provides the accuracy while hydraulics provides the force via a super responsive servo valve. Proper evaluation of the requirements for a particular application can assist a technician with evaluating the performance of a valve and its suitability for the task at hand.